Assalamu alaikum guys, welcome back to another video by Science with Kasmani. So recently I had uploaded a P5 masterclass and then I got many requests from all of you guys to upload a P5 masterclass for physics too. So here I am, and this is going to be the first part of this video. Basically this masterclass has multiple parts. We're going to be covering everything you need to know before your P5 exam on 20th May, I believe. So this is the first part, as I said, and we're gonna have multiple parts coming in at different times of different days before 20th May. So make sure you subscribe so that you're able to get the notifications as soon as I upload the video, and then you're obviously gonna be able to watch the video. Let me know if you have any questions after watching it. I just decided to record the intro after I had completed the class recording. So yeah, any questions, just let me know in the comment section and I would love to be able to help you out. Thank you.
Let's get right on with it. The first thing which you have to know for your P5 is the format of what your paper is actually going to look like if you have absolutely no idea. So just take a look at this. Paper 5 is basically testing three skills of yours. Now, what are these three skills? This is planning, analysis, and evaluation. You're basically gonna have to plan your answer, work out some points of analysis in your answer, and then evaluate some things in your answer. Now, throughout this entire class, we're not going to be talking things in the air. I'm going to give you guys past paper questions side by side, and we're going to keep solving them so that we build understanding of how we actually apply this knowledge to the exam situation. So planning, analysis, and evaluation. You basically are only going to have two questions. That's a guarantee. Every single P5 you open, it's only going to be two questions. And these two questions are of equal marks, as in 15 and 15. That's why they make up 30 in total. Now, what is this 11.5%? Basically, your entire A level grade, right? It is based on your P1 performance. P2, P refers to paper. So, paper 1, which yours your MCQs in AS levels, paper 2, paper 3, paper 4, and the final boss level, paper 5. So, paper 5, you could think of it as just 11.5% of your total A level grade. Right. So, just as we just talked about just a second ago, this paper has two questions, question one and question two. Now, most students face more of a difficulty in question number one because question two is just technical stuff. It is uncertainties, it is finding out the gradient, finding out the y-intercept, plotting a graph, and all of that stuff. That's more mathematical, and you can get that by practice. But question one is something which you have to pay more focus on. So, we're gonna start with question one. Take a look at what question one is asking from you. Basically, if you take a look at any question one in the exam, right, they're gonna give you a very, very long question, and then they're gonna give you 1.5 pages. I'm not even joking. It's 1.5 free pages, and this is basically, think of it as an extended writing question. You have to write paragraphs upon paragraphs, and then eventually you will be able to answer the entire thing. So, if I give you a general idea of what this question is, so let me just write it down. You will be provided with a scenario and slash or a relationship. So basically, in all of these question ones, you're gonna be given a scenario, a situation, or you're gonna be given a relationship between two variables. Your job is to test this relationship between those two variables. So let me write this too. Your job is to test the relationship between these two variables. It's obviously not going to be multiple variables compared with each other or related to each other. It's going to be two variables related to each other, and their relationship is actually what you have to test. Now, let's look at first some general tips and tricks, and then we will zoom into each part of question number one separately. So, some general tips and tricks I have for you is, if in question number one, an apparatus has been explicitly mentioned. So, for example, they say you use a measuring cylinder or you use a Hall probe. Remember, why is Hall probes used? For magnetic flux density. You must have learned this when preparing for P4. If any specific apparatus has been mentioned by their name, you must use it. There is no choice, you have to use it. Other than the extra basic apparatus that you will use, right? For example, let's say if it's an experiment involving volumes of water, like you have to take different volumes of water. How are you going to take different volumes of water? By using a basic apparatus, by using a measuring cylinder. So that's the apparatus which is different. That's the basic apparatus that you're going to use. But some specific apparatus, if they give you in the question, then you must use it. You must write that down when you are planning your entire experiment. And why are you planning your entire experiment? Because you're testing the relationship between these two variables. So, if, and don't worry if you still didn't get any part of everything I talked about so far, the as soon as we go to a past paper question, you're gonna get every part which I'm saying. So, for now, just understand, if an apparatus is mentioned, you must use it. All right. Now, in order to solve this question, right, here's what you should do. Imagine yourself in the lab. Imagine yourself in a physics lab, and then you're actually doing what the question is telling you to do. So just close your eyes while you're in the exam for, like, let's say 2 or 3 minutes so that you can plan out your entire experiment in your head. Imagine yourself doing it. So that's how you are going to be able to properly plan the experiment. The thing is, when you are planning the experiment, there is a few things you should keep in mind. Now, what are these few things? Make sure to draw a diagram if possible. Now, why do I say if possible? In some experiments, it is just so basic, it is just so simple that there is no need to draw a diagram. So, suppose you're measuring lengths. Now, it's basic common sense that you measure lengths with a measuring scale. But in some cases, they ask you to show the orientation of the measuring scale. How do I place the measuring scale on the table? That you have to show using a diagram. Let's say if it's a question about electricity, then you draw the circuit and show it to them. Let's say if you're measuring the volume of something. Now, for example, if you have a ball, right? Take a football or a cricket ball. A football or a cricket ball is a spherical shape. Has there ever been any apparatus invented with which you can get the sphere of the ball? Like, any apparatus can you use with which you can directly get the sphere value, the volume value of the sphere? You can't, right? You have to apply the volume of a sphere formula, which is 4 over 3 pi r cube. You then find out the radius of the sphere. How do you find out the radius of a sphere? You use a measuring tape and you wrap it around the sphere to get the circumference. And the circumference is 2 pi r. And that's how you get r. Or you measure the diameter and then you divide the diameter by 2 to get the radius. You see? Points upon points upon points. How do I get the volume of a sphere? I apply this formula. There is 1 mark for writing this formula. Now, how do you calculate the radius? You use the diameter. How do you calculate the diameter? You use a measuring scale. The more detail you go in while explaining your entire method, your entire thought process, the more marks you're going to be able to gain along the way. And if possible, if you can imagine it do if you can imagine yourself doing it in your head, then draw the diagram. If possible, this is going to be really, really helpful for you in terms of gaining marks. So what are the types of diagrams you could draw? You could draw, for example, how would you use the apparatus? Yeah, that's basically it. How do you use the apparatus? Or if it's an electricity experiment, how would you draw the circuits? How would you set up the circuits? Etc. etc. Right. Point number two. When you're planning the experiment, apart from drawing the diagram, Of course, the main part, you're going to have to explain your procedure, right? How are you going to start the experiment? What's your step number 2, step number 3, step 4, step 5, step 6? How are you going to end the experiment? How are you going to measure this? How are you going to measure that? So, basically, your entire procedure from start to finish. And in the procedure, you include the measurements you will take. Again, just a heads up, I haven't yet started question one. I'm just trying to give you guys a feeler of what this question is. As soon as I start it, I'll let you know. So, procedure and then the measurements I have to take when performing the procedure. And one basic rule of thumb, go into as much detail as possible. All right. What are your control variables going to be? What are control variables? These are basically the variables that you keep constant while you're performing the entire experiment. Number 5, how are you going to analyze your data? So the analysis of the data. And then number 6, the last one, what safety precautions, if needed, would you use for that particular experiment? So, if you now read this through, you're probably gonna get a very, very rough idea of what your answer is going to look like, right? You're going to draw a diagram. You're going to explain your entire procedure. You're going to explain what measurements you take in your procedure, what control variables to keep, what's your independent variable, what's your dependent variable, how would you analyze the data which you record, what safety precautions will you take, how many times will you repeat the experiment, etc., etc. Okay, now we are about to properly start question one. I'm gonna put that picture here up again. Just give me a sec. Where is it? Where is it? Right here. Take a look at what are the 4 skills which you should apply to get 15 out of 15 marks. Also, by the way, 15 marks is the total, which obviously you know means 15 distinct different points, right? 15 points equals 15 marks. I would suggest aim for writing 18 to 19 points. The thing is, not every point you think about is going to be mentioned in the marking scheme. Now, while you are thinking about the experiment in your head, you might be thinking, oh, this is a really important step. I should mention it. Maybe that's in the marking scheme. But turns out it's not in the marking scheme. So if your goal, right, is that, oh, I'm gonna write 15 points to get 15 marks, you're probably gonna end up getting 11 or 12. But if you write 18 or 19 points to get 18 or 19 marks, then you're probably gonna get 15. You know how people say if you wanna achieve 100%, don't aim for 100%, aim for 130%, because you don't really achieve 100% of what you strive out for. So just make sure of that. Okay. Now, the way we're going to understand, right, this entire question, we're going to produce our entire answer, our entire 1.5 page answer, brick by brick. Just like you make your Instagram Reels feed, brick by brick, that's how we're going to solve this entire question. The first brick is going to be solving this, defining the problem. This is brick number 1. Brick number 2 is methods of analysis. And brick number 3 is methods of data collection. Now, all of these words sound pretty fancy, right? Analysis, data collection, defining the problem. It's way too fancy and overcomplicated. Let's try to simplify each one of them separately. So, this is the first brick of our answer, defining the problem. What do we actually need to write for this particular point? For every experiment that you get, this is important, right? For every experiment that you get, you need to write down 3 things under the topic of defining the problem. What are these 3 things? Number 1, you need to write down what your independent variable and what your dependent variable is. That's number one. And that's your first line of the answer. As I said, brick number one, your first part of the answer, second part of the answer, third part of the answer. In your first part of the answer, this one, your first line should be this. This is my independent variable. This is my dependent variable. For those who don't know what independent and dependent variables are, let's just explain it for them. Independent variables are those variables which we are actually changing in the experiment. So, variables that we change in the experiment. Whereas dependent variables are those variables that we measure in the experiment. Let me give you guys an example. Let's take a very, very simple example, right? Let's say we have containers, container number one, container number two, and then container number three. If I ask you, what difference do you see in each of these three containers? Give me one difference. You would say, I can clearly see the difference in their surface areas, right? The surface area of this one is the smallest, then this one is on position number two, and this one is the biggest surface area. Let's say in all of these three containers, I have some water inside them. So I'm gonna just color it using a blue color. So water here, and then water here. Now, the reason why I'm doing this experiment is because I'm trying to test what effect there is on the rate of evaporation if I change the surface area. What effect there is on the change on the rate of evaporation if I change the surface area. What am I changing? The surface area. So what is my independent variable? The surface area, because independent variables are the variables that you change in the experiment. So in our example, surface area is the independent variable. What's your dependent variable? The rate of evaporation. That's what you're seeing, right? For example, this is your container number one. Now, if you increase the surface area, what happens to the rate of evaporation? When you go from container two to three, what now happens to the rate of evaporation? But tell me this, has there ever been any apparatus invented which can directly tell you the rate of evaporation? For example, it can tell you the rate of evaporation is 20 grams per minute. Has there been an apparatus that directly tells you this? No, right? You have to calculate it by measuring other things and not the rate of evaporation. Now, what do I mean by that? Example, let's say you are in a lab, right? And the lab or the examiner tells you to measure the rate at which evaporation takes place. How are you going to measure that? Well, you know that the word rate means whatever they're talking about, you just divide it by time. That's the rate of evaporation, right? So, for example, what is the definition of acceleration? Acceleration is the rate at which velocity changes. So, velocity is changing. Divide this by time. This is now rate at which velocity changes. That's acceleration. So, rate of evaporation is just how much of evaporation is taking place. And because you see the word rate, it means that you can divide it by time. How do you measure how much evaporation has taken place? Well, simple. For each of these containers, use the same amount of time and then measure the amount of mass lost from the container. Let's say 20 grams of water evaporated in 24 hours. 20 grams in 24 hours. Let's say 14 grams evaporated in 24 hours. Again, you keep the same time. And 30 grams evaporated in 24 hours. So now, whatever your answer is, it's going to be in grams per hour. Same case here, grams per hour, grams per hour. And you can clearly see in the same 24 hours, the amount of water lost is increasing. as you increase the surface area. And that makes sense, right? You learned this in chemistry, the in IGCSE chemistry. The more surface area you have, the more water is gonna evaporate off from the container. So you see, were you actually measuring the rate of evaporation? No, you were measuring the amount of mass lost from the container. So this right here is your dependent variable. This is a very, very big misconception, right? Some students are like, no, 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 our dependent variable is rate of evaporation. My question to them is, are you actually measuring this? No, you are calculating this. Then what are you measuring? You're measuring the amount of mass which is lost. And how do you measure that? Final minus initial, final minus initial, final minus initial. So that's your dependent variable right there. And this is the first thing you have to mention when starting out your answer. Number two, what are your control variables? Control variables are basically the variables that you keep constant in the experiments. Now, let's look at the same example which we took earlier, the container and the water in the surface area and rate of evaporation. What do you think are the variables that you need to keep constant? Some people would say you need to keep the same amount of time, right? If you give one container more time and one container less time, the container which you give more time to is going to have a higher rate of evaporation because more water is going to be lost. And here there's going to be a lower amount of water lost or lower mass of water lost because you gave less time for the water to evaporate. And it makes sense. So you give the same amount of time. So time is a control variable. Anything else? You could think of temperature, right? Keep the temperature of the water constant. If the water here is warmer and here it's colder, then this gives this water a head start, right? An advantage. Warmer water is gonna evaporate more quicker compared to colder water. So keep the time constant, keep the temperature constant. These are your control variables. Now, here's a trick. If in the exam you get confused, oh, what's my control variable? I'm not able to figure it out. One simple thing. Think of all of those variables which could affect the dependent variable. Think of all of those variables which could affect the dependent variable. What's your dependent variable here? The amount of water lost. What are the variables that can affect the amount of water being lost from each container? You would say the time in which I allow the experiment to go on for. That's right, time is a control variable. The temperature of the water, that's right, temperature is also a control variable. So you see, just think of all of those variables that could have been in place of the independent variable. But they are not in place of the independent variable because this is the independent variable. In every experiment, there can only be one independent variable. But that doesn't mean that this is the only factor which results in a change in the dependent variable. There could also be other factors, right? And you need to keep those factors constant, which is what we call control variables. Number three, how to keep the control variables constant. Now, what do I mean by that? In your second point, you identified one, or it must be one at least, but let's say more than one, that's better. So, for example, let's say time and temperature. Now, think about how are you going to keep these two variables constant? How do you keep the temperature constant? If you take bio, you know, use a thermostatically controlled water bath. Or you could just say use, for those who don't take biology, how to keep the temperature constant, just use a thermally insulated beaker. Use a beaker which is thermally insulated that does not allow heat to escape. So you keep the temperature constant in each container. How do you keep the time constant? Just use a stopwatch. As soon as the stopwatch hits 24 hours, that's the end of the experiment for this, and this. So basically, start all three at the same time, end all three at the same time. So you keep the time per experiment, the constant or the same as well. Simple as that. Now, I'm going to be honest with you guys. Take a look at this. I'm going to write down how many marks each skill stands for. I'm going to show you guys something. Defining the problem is only for 2 marks. Methods of data collection are for 4 marks. Methods of analysis are 3 marks. So how much is this? 9. And then to make it 15, this is 6 marks. If you are writing 3 things here, how is this equal to 2 marks? Well, let me tell you. If you write the independent and the dependent variable correctly, that's when you get 1 mark. If you write one control variable correctly, just one, that's all I'm asking for, you get 1 more mark right there. That's 2 marks. But then why did I tell you to write another control variable and then also write how to keep the control variables constant? It's because you will be picking out marks from these. Look at what this is. Additional detail including safety considerations. Additional detail means that details which you could add on, which you could explain more and more, like additional details in your experiment. And one of those is safety considerations. But there are many other details apart from safety considerations as well, right? So you could get 1 mark from here and another mark from here in defining the problem. So what I'm trying to explain is additional detail is not a separate part, is not a separate paragraph in your answer. These 6 marks are divided across this and this and this. This is what you have to know. So 2 marks, that's for defining the problem. You got the 2 marks, 1 mark here and 1 mark for writing one control variable. Now, if you have written a second control variable correctly as well, you get one of those additional detail marks. If you have written how to keep all control variables or one control variable constant, you get another mark from this additional details. So the more you explain your experiment, the more marks you're gonna pick up along the way. That's the general rule of thumb in question number 1. So, just as a summary, what do we do in defining the problem? Identify the independent variable, identify the dependent variable, identify the control variables, and how to keep the control variables constant. Let's do some past paper questions from this. I have this question number 1 for you guys. Now I'm going to show you what parts of the question you should specifically be careful when reading, and that's going to get you your first 2 marks for defining the problem under 10 seconds. So let's first read the question slowly. A student, this is from a past paper by the way, a student is interested in bungee jumping, right? Everyone watching this video has heard of bungee jumping. If you haven't, please go on to YouTube and enjoy. A student is interested in bungee jumping where a person attached to an elastic cord falls from a height. So, this is a person initially, or the first part of this entire thing, he was right here, and an elastic cord was attached to him. And now he falls off, or you could say he jumps off this cliff with the elastic cord still attached to him. So the person attached to an elastic cord falls from a height, this entire height. So this is the bridge and this is the ground. So he falls from the bridge and just below the ground he stops. He does not hit the ground, right? Or else he's gonna die. He just falls, or he reaches just towards the ground or just near to the ground, and then he is pulled back upwards. And he travels downwards through a distance before moving upwards. Different chords are used for different people. A schematic diagram is shown in figure 1.1. Now, the student models bungee jumping. So, of course, he's not performing it in real life. He's just modeling it inside of the lab. How does he do that? Instead of using a real person, he just uses loads. And instead of using a very big elastic cord like we do in bungee jumping, he uses small elastic cords. So basically, he's oversimplifying the experiment so that it can be done in the lab compared to in real life. So he models bungee jumping in the laboratory by using elastic cords of unstretched length, 50 centimeters, with different spring constants. Read this sentence again. For each experiment, what type of elastic cord is he using? Every elastic cord has the same unstretched length. Doesn't that mean that the unstretched length is a control variable? The variable that you keep constant. Okay, second part. Different spring constants. What are you changing from one experiment to the other? You're changing the spring constant, hence the word different. What is the name of the variable that you change? Independent or dependent? Independent. So this right here is your independent variable. But again, we haven't read the entire question. We're still not sure. I'm going to put a question mark next to it. There's no question mark needed for this. We are sure this is a control variable. But you're still not sure if this is the independent variable or not. An object is attached to each chord. Now the student investigates the relationship. This is your first sentence which you should look out for. The student investigates the relationship between the maximum distance h. So basically, when he just makes the object fall from the starting position towards the ground, the maximum distance h that the object falls, that's one variable. So, investigating the relationship between the maximum distance fallen by the object and the spring constant k of the elastic cord. What two variables is he talking about? H, maximum distance fallen by the object, and K, spring constant. It is suggested that the relationship H and K is this. Remember, I told you guys in every equation one, you're gonna get a relationship and you have to test it. Design a laboratory experiment to test the relationship between H and K. Okay, now here's the real deal. All you have to do when you're reading the entire question. So my first piece of advice to you guys would be read the entire question slowly, right? No need to jump to conclusions. Read the entire question slowly. As soon as you're done with it, come back to this sentence and then this sentence. What two, and more specifically, this sentence. What two variables are they talking about? What two variables are they trying to test the relationship between? H and K. You see, there were so many other variables in between that we talked about. So L, unstretched length, M, mass of the object, G, gravitational acceleration, and then K, spring constant. So there are so many variables, K, H, L, M, G. How do you know which two are your independent and dependent? This statement right here narrows down all of your many variables to two variables, right? Now you know which two variables are they talking about, which means these two are your independent and dependent variables. Step number one. What was step number one? Take a look at this sentence again and narrow down your choice of options. For example, you might be confused. What if this is the independent variable? What if this is the dependent variable? So now you know which two variables are dependent and independent. Now, question number two. Which one is independent out of these two and which one is dependent? Here's when you have to use basic common sense. What was h? H was the maximum distance fallen by the object, and k was the spring constant. Tell me this. Does the spring constant or does the maximum distance fallen by the object change because of the spring constant? Or does the spring constant change because of the maximum distance fallen by the object? Let me write these two statements again. Does the K spring constant change because of H? Or does the maximum distance, the H, change because of K? Which one is changing because of which one? So which one results in a change to the other one? You would be like, this is common sense, right? If you change the spring constant, that's when the maximum distance changes. It's not the other way around. You can't change h and be like, oh, see, I resulted in a change in the spring constant. No, spring constant is a property of the chord. You can't change the property of the chord by changing something else. You have to change that specifically, if I make sense. So, meaning this statement is correct. Because K changes. What are you changing? Yourself? K. So K is your independent variable. And because K changes, what does that result in? It results in H changing. So this is your dependent variable. And what are you measuring? You're measuring h. What are you changing? You're changing k. Simple as that. Just take a look at this statement, use common sense, and now you know which one is the independent and which one is the dependent. What do you think are your control variables? What trick did I tell you guys for control variables? Think of all of those variables which could have been in place of the independent variable. So think about the experiment, right? How do you think, or what factors do you think could result in different values of h, or would result in the h value changing? You would say maybe the mass of the object, right? The load of the object. If you use a heavier object, it's going to stretch more. It's going to travel a greater h, a greater maximum distance that it falls. You're right. The mass needs to stay the same. Notice this formula. What variables were you given in this formula? Let me write this down on the right. You were given k, h, l, m, g, and then again h, which we have already written it down. It's just repeating again. Out of this, h and k are your independent and dependent variables. Now you're left with three variables. Tell me this. Can an experiment have more than one dependent variable? No. Can an experiment have more than one independent variable? No. Then that means that these three are your control variables, isn't it? So, what did we understand? If in the exam you're confused on what your control variable is, just look at the equation. They will always give you an equation. Out of this equation, just cut down your independent and dependent. The remaining ones are the control variables. But here's the main thing. Do not write those control variables in your answer which are obvious, which are logical. For example, G, acceleration of free fall. Are you actually doing anything? Are you physically doing anything to keep it constant? No, right? It is constant. So there is no point of writing G in this case. So you cut this as well. Now, also don't write those control variables which have already been mentioned. Look at the question. They already told you that we are using the same unstretched length, which was L. So they already are telling you that, okay, we know this is a control variable. You don't need to tell us that again. So cancel this out as well. What are you left with? You're left with M. So M right here is the control variable. Now, never get confused by this. When I'm saying you can use the formula to your help or to your advantage, it doesn't mean that those variables only listed in the formula can qualify to become a control variable. No. Even if you can think of those variables that you think might affect this, might affect your dependent variable, but they are not in the formula, you could write that as well. But this is a very simple question. There's not really any other control variables. If you can think of anything else, just let me know in the comment section and I'll confirm by saying yes or no and then give you the reason for it as well. So, mark number one, mark number two. What's mark number three? How do you keep the control variable constant? How do you make sure that you are using the same load? Simple, just use the same load. So you see, this was so basic, this was so obvious. How do you keep the load constant by using the same load every time? So because it's so obvious, right, you don't really need to write it. And so in this question, you're not going to get the third mark. Right. Let's take a look at another question. Right, pause the video. And what do I need from you guys? Dependent variable, independent variable, control variable, and how to keep the control variable constant. Right, so I expect you guys would have solved this and then resumed. So let's see. A student is investigating the speed of a vehicle on a track when a small ball is projected into the vehicle. So the ball, it hits the vehicle and it causes the vehicle to move, and you're investigating the speed of this vehicle after the ball hits it. The ball is projected towards the vehicle by a compressed spring. Okay, interesting. So you have a compressed spring here. So for example, imagine this, right? You maybe had the ball here and there was a person who pushed this ball inside the spring to compress it. And then they kept their hand there. They didn't remove their hand, otherwise the spring would have pushed the ball, right? So they kept their hand there, keeping the spring compressed. Now, to start the experiment, they just removed their hand, so the spring returned to its original position. And because it returned to its original position, it also pushed the ball towards the vehicle. It is suggested that the relationship between, so it's talking about the relationship between two things. Make sure you read this. It is suggested that the relationship between the speed of the vehicle and the mass m. So this is not the mass of the ball, this is its mass, like the mass of the vehicle. After the ball embeds itself in the vehicle is this, where B, small b is the ball mass, capital B is the vehicle mass. Oh, no, no, sorry. Small b is the ball mass, capital M is the vehicle plus ball mass. K is the spring constant, and X is the compression of the spring. Here's your main sentence that you need to look out for. Design a laboratory experiment to test the relationship between V and M. So now you know your independent and dependent variables are not this, not this, not this. It's these two. Now, use basic common sense. Does the velocity change because of the mass of the vehicle and the ball, or vehicle plus ball? Or does the mass of the vehicle plus ball change because of the velocity? Of course, the velocity changes because of the mass, right? And not the other way around. So now you know that you are actually changing capital M, the mass of the vehicle plus the ball. And that results in a change in the velocity of the vehicle. So that's your dependent variable, the one which you are measuring. What's your control variables? Cancel out the independent and dependent. These three are control variables. Now, have they mentioned any control variables for us already? For example, like in the previous question, they mentioned L, we have already kept it constant, so we can't mention that. But have they said anything like that in this case? Let's see. Uh, they haven't really said that. So you can say you need to keep B constant. So your control variables could be B, the mass of the ball. You could also keep the spring constant the same, and you could also keep the compression of the spring the same. Now, you see, you have three options to write here. I would never suggest writing three control variables. Like, one is, of course, compulsory, two is good. But then three, you're just stretching it, you're just pushing it. So, wouldn't really advise for three, but if you want to, you can. But I would suggest just keep it to two. So, in this case, just select your two best ones. Which one, think of which control variables would you have to do the most extra stuff in order to keep them constant, right? Because if you're doing something basic, more often than not, you're not going to get the mark for this, right? How to keep the control variable constant. So think about it. Are you really doing anything to keep the spring constant the same? No, you're just using the same spring. You're not doing anything crazy or anything extra. So don't write this. You can write keep the same mass of the ball. But again, how do you keep the same mass of the ball by using the same ball? Even that is an obvious case. But again, just choose anyone. I would just say choose the mass of the ball to be the same and then the compression of the spring. Now, this is where something you have to work on, right? Think about it, imagine yourself doing it. How are you going to keep the same compression of the spring in each experiment? That's basically where you get the marks for the procedure, the methods of data collection. This is where your majority marks lie. And you might be thinking, do I only get 4 marks for writing the method? No, these 6 marks are also inside of this. So you probably get 7 or 8 when you combine this and some of these as well. So don't worry about the number of marks, just keep writing in as much detail as possible. Okay, I have one more question and then we are gonna move to the next brick. One second. Yeah, right here. Now, we're gonna be more faster at this, right? So let's quickly read this. A student is investigating how the extension E of an elastic cord depends on the diameter. Extension depending on diameter. Now, some students would be like, why do we read it? Why don't we just read the statement? And more often than not, they're right. You could just read the statement to get the answer. But again, reading the entire question is always a good practice. So you already know it's us comparing E and D. So meaning this, and this. All of these are not your independent or dependent variables, but still let's read it, right? A student is investigating how the extension of an elastic cord is depending on the diameter d of the cord when you apply a force. So basically, he's investigating how much the elastic cord extends if I take different diameters of the same cord and then I apply a force on each of those different cords, which have different diameters. The student has a number of elastic cords of the same material, so he keeps the material the same. That's a control variable. Different diameters, so now you clearly know what they are changing. That's your independent variable. The elastic cords have circular cross sections. Each cord has an unstretched length of approximately 50. So, see, this is one of the control variables which they already talked about. So, writing about this in your answer would not give you an extra mark since it is already mentioned in the question. It is suggested that the extension E and the cross-sectional area A of the chord are related by this expression. So E is the expression, E is the extension, and A is the cross-sectional area of the chord. Capital E versus this is the Young modulus. AS physics, this is Young modulus, which remember was stress applied on the spring divided by strain on a spring. And strain, remember, had no units because it was change in length over original length. Okay. So E is the Young modulus of the material. F is, and remember, Young modulus is a property of the material. So if you're keeping the material the same, you're keeping the Young modulus the same as well, right? So even writing this wouldn't make sense in your answer as a control variable. Let me repeat that part because I think I went too fast. If you're thinking, why can't I mention E as a control variable in my answer? You're right, you could mention it. But the thing is, look at the question. They already mentioned that they are keeping this E the same. How did they mention that? If you remember from AS, Young modulus depends on the type of material of the string or spring of cord or basically anything that stretches, right? The material which that thing is made from, that's what determines their Young modulus. Think about it. If you're using the same material, doesn't that mean you're using the same Young modulus? So even though this is a control variable, this has already been mentioned. So you can't really write this. Okay. F is the force applied on it. L is the unstretched length. And they have also told you that we know that unstretched length is a control variable. So you can't mention this as well. Design a laboratory experiment to test the relationship between E and T. So step number one, apply common sense. Do you change the diameter, which results in a change in the extension? Or do you change the extension and that results in the diameter of the wire changing? The second option does not exist, right? How can you change the diameter by changing the extension? That's not possible. It's the other way around. You change the diameter by using different diameters. So that's your independent variable. What's your dependent variable? The one which you are measuring, your extension. And then what's your control variables? Look at the formula. You can't mention this control variable or this one because they've already mentioned it. This is the independent one. Now notice, this is an interesting question in the sense that the independent variable is not part of the formula. And you might sometimes get this. Don't be confused. It happens. F and A, are these two things we should keep constant? Yes, we should. So F and A are the ones that we need to keep constant in this experiment. Alrighty. So point number three, the last one. How do you keep the control variables constant? How do you keep the force constant? Use the same load each time. Now, this is basic. You might or might not want to write this, but I suggest just writing it down because you don't really have any other option. Yeah, you have eventually. You could also write about the A, right? How do you keep the cross-sectional area of the chord constant? Now, this is something to think about. Why am I saying this? Chord has a circular cross section, right? Chord has a circular cross section. And circular cross section means it's basically a circle. What's the area of a circle? Pi r squared. And r is basically d over 2. My question to you is, if you are changing the diameter, does that mean you're changing the radius? Yes, we are. But then if you're changing the radius, how are we keeping a constant? Think about it. A is pi r squared. If you're changing the diameter, you're changing the radius. If pi is just 3.14, if you're changing the radius, we're also changing a. So is a control variable? No. We identified a mistake of ours or a mistake of mine. A is not a control variable. Now I wrote down a on purpose so that I can explain this mistake. So now the only control variable you have is f. So now you have no other option other than stating the obvious. Use the same load each time. That's going to be your third mark of how to keep the control variable constant. So that's the first part of what we were going to cover in this class. In the next part, we would be covering methods of data analysis, which is basically the second brick that we have to lay down